Hi everyone, Mr. Boltri here bringing you video 3.8, where we're going to talk about another lab that we're going to do in our next class. And this one is trying to quantify the force done by a spring. So first, let's talk just a little bit about other forces that springs do. So springs come in all sorts of different shapes and sizes. Some stretch out, some squish up. So just kind of depends on what kind of spring you're working with, depending on if the spring is going to stretch or squish. In this lab, we're going to be working with some stretchy springs. But it's not only springs that do this elastic force or the force of a spring. Also, any other stretchy thing like a rubber band can also do this elastic or spring force. So then it kind of gets to be a little bit tricky. Like, is this doing a spring force or an elastic force, or is something doing a tension force? And the easiest way to tell the difference between those two things is it's an elastic force or a spring force if the thing is stretching or squishing. And otherwise, if let's say a rope, when you pull something with a rope, the rope doesn't stretch or elongate. So then that would be a tension force. So that's just one easy way to tell the difference between an elastic force and a tension force. But in this video and in this lab, we're going to be focused on that elastic force or the spring force. So the next question is, what determines a spring force? Well, all of these different springs, since they're different shapes and sizes, are going to exert different forces of the spring. So one thing is the shape and the size of a spring, which is why it's going to be important that you not switch springs in the middle of the experiment, because we have springs of different shapes and sizes. So if the red team has one spring and the blue team has another spring, we wouldn't want them to switch in the middle of the experiment, because then that would change the amount of force done by the spring. So make sure you keep your spring the same. Your spring is a constant for the whole experiment, as well as the more you stretch a spring, the more force it's going to do. So here, it might not be doing very much force, but here it's going to be doing more force because it's being pulled down. So then it has to pull back up on this mass. So assuming that it is stationary, therefore it's maintaining a constant velocity, then we know the forces are balanced. So if we can figure out how much force is pulling down on it, then we can say that that equals how much force is pulling up on it. And we know the force pulling up is the force done by the spring. So the two things that determine the force of the spring are the type of spring, like the size, and then how much the spring is stretched. So the next question is, how can we figure out how much a spring is stretched? Well, the two things we need to know is what was its length initially, the unstretched length, and then what is its length now? And then we can figure out how much it's stretched by using this pretty easy formula. And this makes more sense to me with an example. If it had an initial length of 8 centimeters, and then we stretched it to 10 centimeters, or its new length, now that it is being stretched, is 10 centimeters, that means it was stretched by 2 centimeters. So that, hopefully that makes sense to you, because to get from 8 to 10, we had to add 2. So 10 minus 8 is 2. So that's how we can calculate the stretch, which is going to be important. And what I'd like for you to do now is flip to the next available page in your lab notebook and write in big letters at the top, force of the spring lab. And we're going to do the same lab setup that we've been doing all year, just to make sure that we can come to our next class ready to run the lab without any delay. So the question for this lab is going to be, as always, what is the relationship between A and B? So the two things that we're trying to investigate the relationship between is force spring and stretch, and making sure that the type of spring that you use is a constant in the experiment. So make sure you get all this written down in your lab notebook, like I said, so we can come ready to crush the lab in our next class. So in order to investigate this relationship, we're just going to need a couple things. We're going to need a ring stand to hold the spring up, just so it's not laying down on the table. We're going to need a spring. We're going to need a force sensor so that we can pull down on the spring to see how much the spring has to pull back up on. Because if the spring stays stationary, then we know that the forces have to be balanced. And then we're going to need a ruler to look at the stretch. So let me zoom in on that a little bit. We have a spring, which is being held up by a ring stand, a force sensor, so we can pull down, because however much we pull down, we know the spring has to pull up equally in order for the system to keep a constant velocity. And then a ruler where we can measure the initial length and the final length. So get this sketch down, and then I'm going to ask that you write your own procedure. And remember, really, really important, don't say collect data, say exactly what you're measuring and how you're measuring it. So for example, make sure you tell me how you're going to measure the force spring, how you're going to measure the stretch. And once you have your own procedure written, I'm looking forward to looking at those before our next class. The last thing we need to do before we are ready to run the lab is to make our data table. So some information that we're going to need is we need to write down the initial length of the spring, which is going to be a constant. And by initial length, I really should say unstretched length. Because initial can be kind of confusing because when is initial? So yeah, well, let me just go ahead and change this to unstretched length because then we can do when we have the stretched length minus the unstretched length is going to give us the amount of stretch. And I know that's probably a pretty easy calculation that you can do in your head because let's say as if this is 10 centimeters and this is 8 centimeters, you can just do that 2 centimeters in your head. But the reason why we want to write down the final length and write down the initial length is it's important to record all of your data. That just shows all the steps that you did and make sure that if somebody else were to look at your work, A, they could follow your work, B, they could replicate your work, and C, that they know that you didn't fabricate any of your data. So it's important to write down the final length and then actually show that calculation. Final length minus initial length gives you the stretch length. And then the force, we're just going to be reading off the force sensor, knowing that the force down equals the force up. And so then last but not least, we can just go ahead and start thinking about how we're going to graph our data. And just so that everybody graphs their data the same, let's have stretch on the horizontal axis and force spring on the vertical axis. So once you get all this written down in your lab notebook, you are ready to run the force spring lab that we're going to do in our next class. But for now, this is Mr. Boltri wrapping up video 3.8, and hopefully we are ready and excited to run the force spring lab in our next class. But for now, go Bears.